We're going to continue our discussion regarding volume of three-dimensional shapes, and in this video we're going to talk about volume of cones. We've discussed the relationship between prisms and pyramids. Cones and cylinders are very similar, identical in this particular relationship. So let's take a look at our examples. Example number 1, we have a cylinder and cone have the same radius and the same height. So even without, we don't know their measurements, but we are told that they have the same measurement. And so when we look at the volume that was calculated based on those measurements, we can see that the volume of the cone is 3 times less. Okay, so of course you're hopefully seeing that no matter how your shape is positioned, it's still going to be a cylinder and a cone. We're going to use all of these different formats. But once again, if they have the same measurements, that means the radius is the same and the height, the radius the same and the height, which I wanted to mention. You know, radius for the cylinder, we do know how, or the cone, it's going to be very similar. The height for the cone, going to be very similar measure to the pyramids. Goes from the center of the cone to the very top of that apex. So our examples are definitely supporting the formula that we're going to be using, that once we know the area of the base and the height of our shape and we find the product, we simply need to divide by 3. So this is just an additional example how this formula has been created. So volume of the cone is always 1/3 of the volume of cylinder with the same height and radius. And I wanted to mention to you, I know once again when you are looking at your star chart, you are seeing 1/3. Okay, I am always writing the formula as area of the base times the height divided by 3. And so since the base of the cone is a circle, sounds familiar hopefully, this is our discussion of cylinders as well. Area of the base is going to be found by using pi r squared. Let's take a look at our examples. So once again, no matter how your shape is positioned, your height is going to be measured in very specific approach. Okay, where we're going to be observing this relationship right here. Okay, so it's from the apex all the way to the center of your shape. That's going to be our height. All right, let's put this this information to work. So area of the base, height divided by 3. So that's going to look like pi r squared times the height divided by 3. Let's plug in our values. Pi 5 squared times 12 divided by 3. So as always, my suggestion for you to reduce the number as much as you can. For example, 3 and 12 reduced to 4. 25 squared is, I already gave you the answer. 5 squared is 25, times 4 is 100. Pi times 100 will give us a very nice number, 314 cubic inches. So don't forget, write out your formula, plug everything in, simplify, reduce if you can, and you have your answer. And once again, we have cubic inches, cubic centimeters, and so on, because we are working on the volume. All right, second example. In the second example, your cone is very prettily sitting and properly sitting. So yes, this is our base, and this is our height of our cone. Comes from the apex all the way to the center of your shape. So we've identified the height in our earlier analysis. Let's make sure, are we using the 22 centimeter measure? No, we have a measure of diameter. We need the measure of radius. We're going to be using 11 centimeters. So I'm going to go ahead and set up my formula, pi r squared times the height divided by 3. So pi times 11 squared times 10 divided by 3. So these numbers, 10 is not divisible by 3. Pi is not divisible by 3. So in some situations, you might just have to go through the motion of finding your values. And it's going to be okay. It's really not a big deal, but that surely did make the life a lot easier. So at this point, your volume would be 1,267, and, well, we're going to keep it at 66, rounded too soon, and 47 cubic centimeters. Cubic centimeters. All right, so at this point, please take time to practice finding the volume of cylinders and cones.